Everybody, take out your factoring Bible.
I have it.
All right, let's take a look now. All right, this is what you're going to be using for all factoring homework moving forward. All right, so what is step 0?
Standard order.
Standard order, okay? And what does standard order mean?
Decreasing or increasing.
Yeah.
Decreasing or increasing exponents, all right? So either you're going from exponent 2 to exponent 1 to exponent 0, which is your constant term, or you're going from exponent 0 to exponent 1 to exponent 2. All right, so, all right, once you get through putting it in standard order, what is step number 1, Miss Emma?
Factor out GCF.
Factor out the GCF. Now, when you're doing a factoring problem, there's going to be many stages of it. And at each, after you finish one stage, as you begin the next stage, you ask yourself, is there a GCF in this stage? So you continue to pull GCFs because what it does is it reduces the complexity of the polynomial and makes life easier for you. All right. Now, you notice, ladies, after that, there's an arrow that points to the left that says count the number of terms. And you see, ladies, how down the left-hand column, I have information for 2 terms, information for 3 terms, and information for greater than or equal to 4 terms. All right. So, ladies, if you come down and if you got a 2-term polynomial, ladies, okay, what does that step 2 tell you to look for? Difference of 2 squares. And what is the difference of 2 squares going to factor into?
Binomials.
What kind of binomials?
Conjugates.
Conjugates. Perfect. All right, good.
What's the adjective form?
For what?
For conjugates.
Okay.
What's the adjective form?
That's what I'm listening.
Okay, so ladies, now we come down and 3 terms has 2 major steps there. So under the first step for 3 terms, what are you looking for? PST. So when if you've got 3 terms that you have to be factoring, okay, you check to see if it's a PST. And you know how to do that. Okay, you check the first term, is it perfect square? Last term, perfect square. And they have to be positive, okay? And then if that passes that hurdle, then you do what method?
M method.
Reverse. Reverse M method. Okay, square root here, square root there, and bring down the middle sign, right? All right, good. Now, say that it's not a PST. So you go to the next 3-term, step number 4. All right, so it says if not a PST, look for, you'll be looking for a pair of binomial factors, all right? But here there are 2 types of trinomials that you could encounter, okay? Under A, it's the pattern x squared plus bx plus c, all right? So what's the coefficient of the x squared term in that A step?
1.
1. Okay, so if it's a coefficient of 1, you use what you did in 5.7 and 5.8, okay, which is you find factors of C, notice the next line in parentheses, factors of C that add to B. All right? So since you're looking for factors of C, we call this the C method. Well, this is my name for it, the C method. So factors of that C that add to the B. All right? Now, guys, all right, what if the first term, okay, or through reversing it to get another standard order, you can't find a first term that has a coefficient of 1, then you go to part B, okay, which has the general form ax squared plus bx plus c, so a is not equal to 1. Okay, what method do we use here? The AC method, and here it's factors of AC that add to B. So notice the difference between part A and part B. In A, it's the factors, when the coefficient is 1, factors of C that add to B. And when the coefficient of the first term is not 1, you're looking for factors of AC that add to B. So you see the pattern and the parallels? All right, so now guys, if we go to greater than or equal to 4 terms, all right, so what does 5a say?
Group and pairs.
Group in pairs, okay? And what does 5b say?
Group in 3 terms is PST.
Right, and so you'd have 3 terms, that's a PST, and then you'd have another term, all right? And so you're looking for then the difference of 2 squares in that aspect. All right, ladies, now what does step 6 say?
Make sure each factor is prime.
Right, now, okay, guys, if it's a monomial, then it's prime, okay? If in the binomials, okay, the exponent on the variable, or the implied exponent, is 1, then that's prime as well. It's only when the exponent on the variable is 2 or more that you look for the possibility of factoring more. So, but when you finish what you think you've finished, okay, you ask, can I factor any further? And you have to get down everything to prime. All right? So make sure you follow that. All right, and number 7, guys? What is- Check by multiplying the factors together by, FOIL if you've only got 2 binomials. Okay, FOIL plus distribution if you got more.